Okay, let's give you guys some more practice. Now, imagine you're on a different building now, but this building happens to be on Jupiter now. By the way, Jupiter is just a ball of gas. There's no platform, there's no ground in which a building can stand. So you can't. If I were to drop you on Jupiter, you would just keep on falling and falling and falling. There's no ground on which you could stand on. So Jupiter is just a gas, but for our case, imagine there's ground for us to place a building. So now our building here is on Jupiter. The gravity of Jupiter is 23 point something. Okay, let's just round it off to 23. So let's say the gravity on Jupiter is 23. Now I want you to draw this picture, and here, for each of these here. So this one here is t equals, hang on, 0, 1, 2, 3, 4. So this one's t equals 4. Write it as this: t equals 4, comma, and write in speed equals. Now fill in this blank and then write meters per second in there. Put the unit in there, and then also do distance equals, fill in the blank and put in meters, because the unit of distance is meters, and do that for each of these here. Okay. Well, remember our acceleration time graph for this cannonball will be, well, on Earth is 10, on the Moon it's 2, and on Jupiter, well, Jupiter's 23, so it's miles up here somewhere, 23, and our speed time graph on Earth, let's say it should be steeper. Let's say it's on Earth is the gradient is 10, okay. On the Moon is probably somewhere like this. But on Jupiter, it's a lot steeper. So our speed time graph looks like something like this. Okay. And if you want to sketch the distance time graph on Earth, is something like this. Okay. Remember, it's in it's similar to y equals Freefall is h equals gt squared over 2. Well, this line here is actually gt squared over 2 as well. Well, anyway, the distance time graph for Earth looks something like this. On the Moon is probably shallower, something like that. On Jupiter is a lot steeper. Anyway, the question is, find out the speed and the distance for each of these. Okay, so press pause and have a go. Okay, so the answer should be this. Hang on. So when time equals 0, the speed is 0 and the distance covered will be 0. So this bit here is here. Okay. When time equals 1, so this is after 1 second, the speed is 23, the distance covered will be 11.5. So that will be here, and this will be here, and this will be here. Oh, well, when you worked out the distance, you could either use, hang on, you could either use h equals gt squared over 2, or you could just quickly sketch the speed time graph. So for example, hang on, let's say if you wanted to know, let's say after 4 seconds, okay, what's the distance after 4 seconds? You could just quickly sketch your speed time graph. So this, after 4 seconds, well, this distance here is 4, and then this height here, well, if the acceleration is 23, then this must be s equals 23t. So put the 4 into here. So 4 times 23, 4 times 23. So this will be 12, carry the 1, 8, 9, 92. So the height here is 92. Okay, so you get 92 times 4, okay, because the across here is 4, and then divided by 2, and it should give you this distance here. Okay, or, well, remember, if you want to find out the distance, either sketch the speed time graph, or use h equals gt squared over 2. Memorize this. This is very useful. So this here, well, after 4 seconds, so it's 1, 2, 3, 4. So this bit here represents this. This here represents this point here. This is this point here. This is this point here. Oh, by the way, the height of our building is 414, because if it takes 6 seconds for our cannonball to hit the ground, then the height of our building must be 414 meters. Okay, so anyway, this is your answer here.